Okay, so now we're going to prove corresponding angles converse theorem. So let's understand what this one's saying. It's saying that if you have these two lines, L and M, and then you have these angles, if you have any pair, I just picked these two, right? You have any pair of corresponding angles. So I could show this being true. If we find out that 1 is the same thing as 5, then you know that these two lines are parallel. That's what this theorem states. We need to show that being true. And I just picked two corresponding angles as being congruent, and you could run through this argument very similarly for 1 and 5, 4 and 8, and so forth and so forth. So let's start off. Let's do this, okay? And then now, how do we do this one? This one is a more abstract proof, okay? So why is it abstract? Because we need to understand what's known as a proof by contradiction. So let's first take a side note and understand this idea before we write this proof. So proof by contradiction, what does it mean? Assume, okay, so you have something, it says if B, then, I don't know, C, whatever, okay? And you assume, so you have B is true, right? If B is true, then C is true. You want to start off with saying B is true, and you assume C is false, let's say. Okay, so you have B is true, and you assume C is false. From C being false, okay, from C being false, you can show that D is then true. And then from D being true, you could show that E is true. And then from E being true, you could show B is false. And this is now a contradiction because you said B is true to begin with, and now you have B being false and true. And then that means that your assumption is wrong. The whole thing is that you assume C is false. You don't know, but assume it false. Then that implies that D is true. Then D being true implies that E is true. And then E being true shows that B is false. But you started off with B being true. This is known as a contradiction. And you could write the contradiction like this, the two arrows pointing towards one another. This is a contradiction. And once you have the contradiction, where did the contradiction come from? It came from the assumption, which means that the assumption must be false. Assumption is false. And then you can say that C is true. And you proved that C is true, what you wanted to end with. Okay, this is the idea of proof by contradiction. This must make sense. Otherwise, this proof will not make sense and you will not be able to do this. So let's do this now. Let's see. Okay. So in this case, we want to assume that L is not parallel to M. Okay? So if L is not parallel to M, that means immediately that they must intersect, because L being parallel to M means that they don't intersect. So L not being parallel to M means that they do intersect. Then you could say, or thus, L and M must intersect at some point E. And at this point, it is like outrageously helpful to draw what this picture now looks like. So you have this given to you, right? And now you know that L and M actually, or you're assuming that these two lines are not parallel. So that means that L and M do intersect. So you want to draw the diagram again with L and M intersecting. And then some other line. Okay, and then now what do you have here? You got, this is L, this is M, and they intersect at some point E. Here's E, or better yet, we should put it on the inside so it's clear that when I talk about E, I'm going to refer to it as this point and then as this angle right here. Okay, and then now how does this all translate? So L is here, M is here, 2 is right here, angle 2 is right there, 3 is over here, and then 6 is over here. And I know I'm given that 2 is the same as 6. Okay, now since, okay, L and M intersect at some point E, you have triangle, whatever you want to call it, ABE. Triangle ABE is formed. And I think it's best if we say that triangle ABE is formed, thus all of its internal, or all, let's state this as an axiom, all all interior angles of a triangle are greater than 0. Okay, so then we have measure of angle E must be greater than 0. Okay, now I can say that this is a triangle, right? This triangle right here. And if we look at it, we should see that if I draw this picture over here, right? Let's say this is A, B, C, and D. We should see that A plus B is equal to D by exterior angles theorem. Okay, there's other ways to get the contradiction, right? But I think it's fastest if we look at this picture and we say, okay, well, isn't it true that you have this angle plus this angle equaling 180, and then this plus this equaling 180, you subtract C on both sides and you get A plus B is equal to D, right? So in this picture, you should see it as 6 plus 3, 6 plus E is equal to 2, right? A plus B is equal to D, 6 plus E is equal to 2. So we're going to write measure of angle 6 plus measure of angle E is equal to measure of angle 2 by exterior angles theorem. Now we're given the fact, right? We're given that 2 is the same as 6. So angle 2 is congruent to angle 6 by given. And then the measure of 2 is equal to the measure of 6 by definition of congruent angles. Okay, and then you can substitute. You could say, instead of writing measure of 6 here, I could write measure of 2. Measure of 2 plus measure of angle E is equal to measure of angle 2. And then, right, by substitution, and then by subtraction, you get that the measure of angle E is 0. All right, when I minus measure of angle 2 on both sides by subtraction. And this is a clear contradiction, because the measure of angle E cannot be 0 if a triangle is formed. Triangle ABE is formed, thus all interior angles of a triangle are greater than 0, or the measure, all interior angle measure angles, whatever, the angle, this is fine, are greater than 0, okay? So we just said though that and then E, because E is an interior angle in this triangle, we say that then E must be greater than 0, but here we're showing that E is 0. This is a contradiction. And you need to write this. This is a contradiction. Okay? These two together, this here and this here, is a contradiction. Okay? Assumption is wrong. The assumption is false. And what's the falsity of the assumption? The assumption is that L is not parallel to M in the very beginning. And then this assumption led to this contradiction, meaning that the assumption must be false, and then you have L must be parallel to M. What did I do? L is parallel to M. What am I doing? L is parallel to M. And now you're done. Now you put the box.